Dear student, let me start the estimation of sulphate by gravimetric method. So, before this already you know it, TDS, that is total dissolved salts in the water. That is also we can call it as a hardness, in that hardness, total hardness. Any of these permanent hardness or temporary hardness of salts is dissolved in the water. It is expressed in the ppm of calcium carbonate. As the same way, we are going to estimate the sulphate also that is there. What we have estimated the hardness through volumetric method. That is volumetric method. This is gravimetric method. So what is in the volumetric method? One standard solution is required. Another analyte or to be tested solution is both. Wherever you are going to experiment is there. It is both. These are standard solution and another unknown solution is required. As the same unknown solution, other reagents you can prepare it and titrate it against with the standard solution. What you got the volume of consumption of standard solution. So based on that, so you can take the three trials. Based on the burette reading, you are going to estimation of hardness. In the hardness, standard solution is EDTA. Consumption of EDTA is helpful to calculate this how much of hardness. That is 1000 ml of 1 molar EDTA contains 100 grams of calcium carbonate. Unit is calcium carbonate. Molecular weight of the calcium carbonate is 100. So for 100 grams of calcium carbonate contains. This is the standard rate. So that is for volumetric. What about for this gravimetric? If it is extended of volumetric is you can taking into the beaker, one beaker 500 or 1000 ml of glass beaker you have to take and pour this complete unknown solution and other reagent to that. You boiled it. So boiling, water is evaporated. Finally, what you can get it in this beaker contains are the solids or what is in the traces of inside the beaker, we can remove it and weigh through the electronics balance, that is gram. This method is called gravimetric method. So what you can get the end point at that time, what it contains in the 250 ml of volumetric flask, you boil that, you weigh this in, weigh that solids retaining in the cuvette, that is only the gravimetric method. So for finally what we can conclude, for gravimetric method, no need of standard solution because what you can get the ml, that is burette reading you can get it. So what is the total volume? So total volume of how many ml is there in the conical flask? Everything is going to estimation based on the 1000 ml of 1 liter EDTA contains 100 grams. Here, no need of that standard solution. Even in that standard solution, no need of that 1000 ml we are using. Instead of that, what is the molecular weight of the given crystals? So in this estimation of sulphate through gravimetric methods, we can take in the water sample. So collect the water sample. In that, you can instead of pipette out, you can measuring the 200 ml in a 500 or 1 liter beaker, glass beaker. You can taking into that. Afterwards, you can add 1 or 2 drops of methyl red indicator. These are the acidic indicators. When the water sample, if it is in the acidic nature, it can exhibit its colors. At the time, you can tell given water sample is either neutral or acidic. If it is exhibits its color, that is look like an end point. If not shows the any color, at the time given water sample is alkaline solution, not acidic solution. So in this, based on this characteristic feature, we are taking the 200 ml of water, add 1 or 2 drops of methyl red indicators. It should not show its colors. it exhibit its red color, at the time you are adding of 5 to 6 drops of concentrated HCl to that. When it is adding, finally you can get end point look like of end point, that is pink color is developed in the 200 ml beaker containing. So it is enough. So that is, you can keep it on the oven, keep it in the oven, or keep it on this Bunsen burner for heating the boiling the water sample. So after this evaporation of the water going on continue, this 1 ml is less, 2 ml is less, 3 ml is less, because boiling point of the water is 100 degrees centigrade. Continuously evaporation of the water, if we have taken 200 ml, if it is come 199 ml, 198, 175, 150, so then it is 100, then it is 75, then it is 50. Near 50 or 40 ml of water. Remaining 160 or 150. 3/4 of the water sample is completely evaporated, but dissolved salts are in the given container. In the beaker containing contains the all the salts, that is complete salt, but water is evaporated. So at the time you are adding barium chloride. So standard look like if you can calculate it and prepare the barium chloride 1 molar solution. You can add 1 ml, 2 ml, 3 ml. Completely, finally we will get one precipitate. You can little bit 1 or 2 drops you are adding the barium chloride also. Barium sulphate has formed and settled down at the bottom. So this is the precipitation reaction. So I think all you are know about of the what is precipitation. You mixing of two dissolved solution, you can prepare or creating of one unknown solution, one undissolved salt as rises, one undissolved salt as created by two dissolved solutions, we can call it as a precipitation. Already sulphate is dissolved, no precipitation. You can add HCl, no precipitation. You can add methyl red, no precipitation. So you can add any ml. How much of ml is required to complete precipitation of barium chloride? You can add it. So barium sulphate has formed, that is settled down at the bottom. So afterwards, little bit you can continue the heating of the solution. 1 or 2 ml or 5 ml is evaporated in the in that beaker. So afterwards, you can cool it and filter it. Filter it, wash with water. Then you can again heat it. Heat the remaining salt. What is you can filter? Taking the filter, throw this supernatant in that filtrate or in that residue. We want that residue. That residue you can heat it. So up to the maximum 900,000 degrees centigrade. Any percentage of water is there in the given barium sulphate salt is completely evaporated. That you can weigh it. Weigh it. How much gram is there? You can note down. That is, we can call it as W. W of that is look like of preparation of the standard solution. You can weigh the total weight of that crucible along with this salt of that is W1. Then it is pour on the paper. You can weigh the empty crucible. We can call it as W2 followed by, so what is that? W is W1 minus W2. You can get it. The W is the out of this 200 ml of water sample containing this much of a salt. For this experiment is over. The observation is over. The remaining part is calculation. In that calculation, so we have not using of any standard solution. So we have taken as a barium chloride. In that we have taken barium sulphate. So in the prepare the barium sulphate. So barium sulphate molecular weight is 233 grams. The 233 grams of barium sulphate containing 96.06 gram of sulphate. So out of this barium BaSO4, out of this sulphate molecular weight is 96. 233 grams of barium sulphate containing 96 grams of sulphate. So that is 96.06 is in the numerator, 233.04 is in the denominator. So multiplied in the numerator is W. W means how much grams of barium sulfate already you can precipitate it and separate it. You can multiply divided by 200. Why do you divide it by 200? Because you have measured the 200 ml of water sample. You have measured the 300 ml divided by 300 ml. You measure the 100 ml divided by 100. You measure the 50 ml divided by 50. W by 50. W, we have taken W by 200. So 96.06 into W, that is what you can got the weight of the sulfate, divided by 233.04 into 200, because we have taken the 200 ml. So multiplied by 1000, because what you can get the salt, that is the barium sulfate, is there in the 200 ml, divided by 200, you can get 1 ml. So 1 ml into 1000, 1000 ml you will get it. So this is the final answer. So coming this, given in the water containing in the range, maximum is 5 milligrams of barium sulfate is there, no problem for drinking purposes also. But in this boiler, it is complete, everything is 2 ppm, only the 2 milligrams, and not beyond that any impurities are there, not ranging of 2 milligrams per liter of water content. So far it is what is there, we can label. So in that estimation, in that under the range, it is possible to use, we can use it. Otherwise, we can, how much is maximum is there, you can separate the sulfate from that water. Then we can label it is fit for drinking or any others also. This is we can using of estimation of sulfate by gravimetric method. After estimation of the barium, that is sulfate, in the gravimetric method, the one more method is there, that is colorimetric method. Estimation of the fluoride by colorimetric method using of a Spadon reagents. So in this, so it is colorimetric. We are using instrument. This is the example of instrument we have used. It is for qualitative estimations of whether it is, we can estimations of the sulfate also through colorimetric method. So any, whether it is a carbonate, whether it is sulfate, whether it is chloride, fluoride, iodide, anything is there, we can estimation through quantitatives also. Here we can estimations also qualitatives also. In the estimation of any of the impurities in the water through quantitative methods are, one is volumetric method, another one is gravimetric method. In the qualitative methods, spectrophotometer, fluorescence method, colorimeters, any other methods, any other instruments we are also using also. Very accurate, not even 0.000 milligrams also we cannot neglect it. We have to consider. So for estimation of fluoride through colorimetric method using of a Spadon reagents. So because without this Spadon reagents, we cannot estimate the fluoride in the given water sample. So far we are using the both the name, using of colorimetry, estimation of fluoride in the colorimeter. Using of this reagents, we can complete the name is estimation of fluoride through colorimeter by Spadon's reagent. So in this, you prepare the Spadon's reagent. How do we prepare this Spadon is 958 milligrams of Spadon reagents. You can weigh through the electronic balance and dissolve in 500 ml of DM water. Completely you can stir it, completely dissolved, keep it aside. Then you can weigh zirconyl chloride crystals 133 milligram. 133 milligram you can accurately weigh. That is dissolved in 150 ml of DM water. Then you can add 350 ml of HCl. So you can concentrated HCl you have taken is 350 ml. You can mix this 350 ml with 150 ml of octahydrated zirconyl chloride solution. That is zirconyl chloride salt is dissolved in 150 ml. So that is zirconyl chloride also for 500 ml. This is also 500 ml. Both we can mix it. Then we can call it as zirconyl chloride Spartans reagent. We have prepared 1 liter of a zirconyl chloride Spartans reagent. Keep aside. If you want the estimate of fluoride from in the given water sample, you prepare the standard solution of sodium fluoride. If you want to find out the chloride in the water, you prepare the standard solution of sodium chloride. If you want to prepare the iodide from the given water sample, you prepare the standard solution of sodium iodide. In that, the example we have taken is sodium fluoride. This water sample containing fluoride or not, you prepare the standard solution of sodium fluoride. Water solution is containing the sulphate, you prepare the barium sulphate or sodium sulphate, prepare the standard solution. Like this, we are preparing for colorimetry same standard solution, because this is colorimetry is photocolorimetry. That means the light is passing through a cuvette through this solution. The absorbance, the solution is how much of absorbance of light rays. Based on that, the maximum absorption takes place with the alpha known concentration under the visible spectrum. This is the principle. The colorimeter is constructed based on the Beers-Lambert's law. Beers' law is the absorbance emitted rays absorbance increases arithmetically as the decreases of exponentially as decreases of arithmetically. It is the absorbance is increases. Absorbance is increases. The percentage of emitted rays is decreases. Thickness is increases. Absorbance increases. Emitted rays are decreases. As the same. First one is Beers' law. Thickness is Lambert's law. Beers-Lambert's law is increase the color and thickness of the solution, the decreases of the emitted rays based on the concentration. This is, we can call it as a photocolorimetry. Using of this light, how much of absorption. So based on this, we are going to estimation. That is colorimeter principles. What is defined colorimetry? Chemical analysis to the given sample under the visible spectrum. Region of visible spectrum means 400 to 700 nanometer with known concentration of the solutions. This is, we can call it as colorimeter. So far, we have prepared the standard solution of 1 gram of sodium fluoride is, you can weight dissolved in 1 liter. This is, we can call it as 1000 ppm of sodium fluoride solution. We want only the 10 ppm of sodium fluoride solution. We want, so far, pipette out the 10 ml of sodium fluoride starch solution. The 10 ml is again we dissolved in 1 liter of DM water. That is, we labeled as a 10 ppm of sodium fluoride solution. First one is 1000 ppm standard solution or starch solution. Second one is 10 ppm of sodium fluoride solution. We want this 10 ppm of sodium fluoride solution. So this you can keep aside also. Take the water sample, that is also keep aside also. Followed by the zirconyl chloride already you have prepared, keep aside also. Then you will take it as a sodium bisulfate. Sodium bisulfate we can commonly add it. Otherwise sodium arsenic, sodium sodium arsenic oxide also you have taken. So this everything is keep aside. Afterwards you take the colorimeter also, setting this absorbance of the light radiation under the 570 nanometer. You set to the 570 nanometer also. You will take 6 to 7 50 ml of volumetric plus. You will take 100 ml also. At least you will take the 50 ml of 5 to 6, totally 7 volumetric you will taking and labeling as 1, 2, 3, 4, 5. So this is for only, again you will prepare the series of standard solution. In this labeled as a, first one is 2 ml, labeling as first, second, third, fourth. So in that fifth also, first one containing 2 ml of 10 ppm sodium fluoride solution. Second one contains 4 ml of sodium fluoride solution. Third one is 6 ml of sodium fluoride solution. Fourth one is 8 ml of sodium fluoride. Fifth one is 10 ml of sodium fluoride. This is what we can call it as series of standard solution. To this you can add, that is one drop one drop of sodium bisulfite or sodium arsenate also you can add it. So afterwards you can take one more, sixth one you have to take, that is test solution. You will take either you want 5 ml of water sample or 10 ml. So fifth one is we have taken the sodium fluoride 10 ml. This is also you will take 10 ml of water sample. To that add 10 ml of sodium fluoride also. So it is, keep aside all these things. Along with you will prepare one more 50 ml of volumetric flask you have taken. To that you can add no sodium fluoride. No sodium fluoride you can add. So next is 10 ml. To all this you can taking it as 10 ml of zirconyl spadance reagent. So first one, it is blank solution. Only 10 ml of zirconyl spadance reagents remaining. So there is one drop of sodium arsenate or sodium bisulfate, one drop you can add. Then 40 ml of DM water you can fill it, keep aside. You will take number 1, it contains 2 ml of sodium fluoride, 10 ml of zirconyl spadance reagent, then remaining 10 plus 2, 12 ml, the 1 drop of sodium bisulfite, the remaining 38 ml of DM water you can add. Up to the mark you can prepare this series standards of solution. Second one, it contains 4 ml of sodium fluoride, 10 ml of zirconyl spadance, 1 drop of sodium arsenate or sodium bisulfite, plus 36 ml of DM water, like this. So each 2 ml plus 10, 4 ml plus 10, 6 ml plus 10, 8 ml plus 10, 10 ml plus 10 ml of this. Totally 20 ml of zirconyl spadance and as well as standard solution. You can add it as 38 ml of DM water, 36, 34, 32, 30. Fifth one is containing 10 ml of sodium fluoride, 10 ml of zirconyl spadance reagent, 20 ml remaining 30 ml of DM water. The water sample is what you have taken, 10 ml of water sample you have taken. So 10 ml of zirconyl spadance reagent you can add it, remaining 30 ml of DM water. In this fifth one is comparing and test solution is 10 ml of sodium fluoride, 10 ml of zirconyl spadance reagent, finally 30 ml of DM water. Here 10 ml of water sample, 10 ml of zirconyl spadance reagent, 30 ml of DM water. Here the test solution should not containing any standard sodium fluoride solution. This is, we have prepared the series of standard solutions, blank solution, test solution. Then you will take the colorimetry, set into this 570 nanometer, because maximum absorption takes place based on their thickness as well as dissolved salts, color, everything is there, maximum absorption. You can take the first solution, that is blank solution. Blank means it only containing zirconyl spadance reagent followed by 40 ml of DM water. So we call it as blank. Blank means no series of standard sodium fluoride. Blank in that not containing a standard solution. You can calibrate the instrumentation, make it 0. Then you will take one notebook, draw the 2 lines, we prepare the 2 columns. In first column, volume of sodium fluoride. Second column is absorbance. Then you can take it as 0, 0 of sodium fluoride in blank solution. the absorbance is also 0 because we are calibrated. So then we can taking the first one through this blank solution, you will take small quantities and pour into the cuvette. Cuvette means it is a small test tube, so it is 100% passing of lights. Now, nothing light rays are absorbed. That type of borosilicate glass small test tube you can call it as a cuvette. You keep it into this air space providing. You setting the calibrated for 0 to the blank solution. Then you will take first number and fill this first volumetric flask solutions. You can measuring the absorbance. You can read it. You pour it. Take the second one. Fill this second number sodium fluoride standard solution. Absorbance is you can read it. Third one you will fill it. Reading the absorbance. Fourth one you can fill it. Read the absorbance. Fifth one you can fill it, read the absorbance. How you can taking into this content, that is the thickness or standard solution series 2 1 multiplication, as the same way. Example is 0.06 or 2 ml is 0.06, 4 ml is 0.12, 6 ml is 0.18, like this. 2 1s are 6 ones. In that you will get it as finally, so in the 10 ml you will get it as 0.30 absorbance. You will plot the graph. In the y-axis is absorbance, x-axis is volume of a sodium fluoride solution. 2 4 6 8. So here also absorbance. So finally, we'll mark on this x and y-axis. You will get one straight line. We call it as a calibration curve. It holds good or satisfy the absorbance versus and concentration. So with satisfying of Beer's lambda, you will get a straight line. That is enough. This is last one test solution also you can observe. The fifth solution, if you got 0.03 is absorbance. If you got 0.03, immediately decide how much of this 10 ml, 10 ml, 0.03, so 10 milligram is dissolved in 1 liter. Suppose you will got 0.15, 0.30, 10 milligrams, 0.15, automatically you can estimate that is 5 milligrams of fluoride is there in given water sample. So based on this, experiment is over. Afterwards you plot the graph and with the help of calculation, how this is sodium fluoride total weight you can calculate. This fluoride is only 19. So out of this 42, so you can taking as 19 grams of fluoride into this. How much of ml you got it, you can label. Under that, how much ml you have taken? 10 ml divided by 10 ml. So that is 10 ml contains this much into 1000. Finally, how much milligrams of fluoride is contained in the given water? You can test it through colorimetrically. So if it is under the range, you can fit, it is fit for drinking. If it is beyond the range, it is over. It is not possible to drinking. If you want excess fluoride is there, it can decaying of the tooth near beyond this towards of Kolar and Chikbalapur district. We can getting the water from the underground at the time. Too much of fluoride, more than 2 gram, more than 1 gram of fluoride is there, that decays the tooth and it is affected to the bones also. So for how much of excess beyond the range of fluoride is there in the water, if you want to drink, remove that much of fluoride from the water, then we can use it for all the purposes. Otherwise, it is look like a wastewater. We can't use for any purpose also. Okay, thank you.